Hey guys, welcome back to my channel Physics Learner. Today in this video I am going to discuss some important topics from electrostatics. Here are the topics to be discussed in this video. My first topic to be discussed is quantization of charge. Secondly, I will discuss charge distribution. The third topic to be discussed is Coulomb's law, and the fourth one is comparison between electrostatic force and gravitational force, and the fifth one is unit and dimension of epsilon zero. In this video you will come to know what is epsilon zero, and the sixth one is dielectric constant, and the last topic to be discussed is superposition principle. First of all, let me tell you what is electrostatics. Electrostatic is that chapter in which we will discuss all the phenomenon related to a charge in static condition. So let's start the first topic, quantization of charge. First of all, one thing you have to remember, that charges can neither be created nor it can be destroyed, which is called conservation of charge principle. But what we can do is we can transfer charge from one body to another body, but the quanta of charge is electron. So if we want to transfer a charge from one body to another body, then we have to transfer one electron from one body to other body. Let us consider two body A and B. Here is a body A and here is another body B. Now let us suppose that an electron is transferred from A to B. One electron is transferred from A to the body B. Then what will happen? The body A will become unit amount of positively charged and the body B will become unit amount of negatively charged. Now if we transfer another electron from this body to this body, then it will become another positively charged. So the charge in this body will become plus 2e and in this body it will become minus 2e. What we cannot do, we cannot transfer any fraction of electron from this body to this body. That means the amount of possible charge in one body is a integral multiple of electronic charge. That means in any body the amount of charge is obviously can be expressed as charge in the body is capital Q is a integral multiple of electronic charge that may be either positive or negative. That depends upon the fact that electron is transferred or electron received by the body. On that fact the nature of the charge will depend. So overall the charge of a body can be expressed as capital Q is equal to plus minus n into E, where n is any integral number, that may be 1, 2, 3 or whatever. So this equation actually establishes the fact, the quantization of charge principle. Now let us discuss what type of questions may be asked from this topic. Let us consider that you are asked a body has a charge 7 into 10 to the power minus 19 Coulomb. Is it possible or not? So the amount of charge in the body is given 7 into 10 to the power minus 19 Coulomb. If it is given positively charged, so you have to use the positive sign here. So n into electronic charge. Now we know the electronic charge is 1.6, actually it is 1.602, you may consider 1.6 into 10 to the power minus 19 Coulomb. The unit matches in both sides. So it becomes the value of n is equal to 7 into 10 to the power minus 19 upon 1.6 into 10 to the power minus 19. So the value of n actually becomes 7 over 1.6. Now you can see here the value of n is a fraction, it is not an integer. So this amount of charge cannot be given to any body. But if you asked that the amount of charge in a body is 6.4 into 10 to the power minus 19 Coulomb, is it possible or not? It is given that the amount of charge is positive. So let us fit the value in this equation. What I will get? It is 6.4 into 10 to the power minus 19 is equal to n into 1.6 into 10 to the power minus 19. So the value of n becomes 4. That means this amount of charge can be given to this body because the value of n here is an integer. So this amount of charge can be given to this body. Now let's come to the second topic. As in the topic 1, I have Consider the situation that some body is given some amount of charge that may be either positive or negative, that has to be a integral multiple of electronic charge. Now what happens that you have given some amount of charge to a body, now the charge will be distributed in that body. That distribution can occur in three ways if it is distributed in continuous way, but if can be also distributed in a discrete way. From this consideration, the distribution of charge can be categorized into two ways. Number one is discrete distribution of charge, where some amount of charge is given in a discrete way like this. This is called discrete distribution of charge. But if you distribute the charge in a continuous way, then there can occur three types of distribution of charge. Number one is linear distribution of charge, number two is surface distribution of charge, and number three is volume distribution of charge. Suppose that there is a conducting body of a linear shape and you have given some amount of positive charge to this body. The charge which you have given will be distributed in this body in a uniform way. Now you consider a small elemental length dl here, where the amount of charge distributed is dq. Small amount of charge will lie here. So the amount of charge in this small element dl is dq. Here the linear density of charge is defined as lambda is equal to dq over dl. This is called linear density of charge. Lambda is equal to dq over dl. Next we consider a surface where some amount of charge is also given, and as it is a conductor, so the charge will be uniformly distributed over the surface. The distribution of the surface charge depends on the curvature of the surface. I will discuss this in later. The amount of charge density is defined as sigma, small sigma, is equal to dq over ds, where ds is a small elemental surface here, where the amount of charge in this ds element is dq. This is how the surface distribution density of charge is defined. In a similar way, if you consider a volume where some amount of charge is distributed and you consider a small elemental volume dv here, where the amount of charge is dq, then the volume density of charge is defined as rho is equal to dq over dv. Now let us discuss something more about surface distribution of charge. Consider that there is a sphere of radius r. This is a sphere of radius r, where capital Q amount of positive charge is given. This charge will be uniformly distributed over the entire surface. It can be experimentally proved that the charge which is distributed over a conducting surface lies on its outer surface. It was proved by Faraday's famous experiment, butterfly net experiment, from which it was proved that charges lies on the outer surface of any conductor. Now for this sphere, the charge is distributed over its surface. So the charge density here is sigma is equal to q over its surface area, which is nothing but 4 pi r square. So here you see that this q is constant and that 4 pi is also constant. So from this, the amount of surface density of charge is proportional to 1 by r square. Now if the shape of the body is not so regular, then what will happen? Consider a body like this. In that case, if you given to this body the same amount of positive charge, capital Q, in that case the distribution of charge will not be uniform. The region where the radius of curvature is very small, that is the surface is very much curved. On this region, that is this region, here the surface is very much curved compared to this one. In this region the charge density will be very large. That is, the distribution of charge is something like this. If you look at the figure, then you can see that the density of charge in this region is very high compared to this region. From this we can conclude that this density of charge, surface density of charge, depends on the radius of curvature. If the radius of curvature is very small, then surface density of charge is very large. The concept that the charge density is very high at a very sharp edge is used in lightning arrestor. Now I will go to the next topic, that is Coulomb's law states that the amount of force between two point charges which is at rest condition is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The force may be attractive or repulsive, that depends upon the nature of the charge. That is, if the charges both are positive or negative, in that case the force will be repulsive, and if the charges are opposite kind, that is one is positive another is negative, in that case the force will be attractive. Let us express the law in mathematical. The force between two point charges is directly proportional to the product of the charges, where I have considered two charges, one is q1, another is q2, are situated. The distance between them is r, and the force is also proportional to 1 by r square. Now combining these two, I can write the force between the two charges is directly proportional to q1 q2 by r square. Now I can write F is equal to some constant k into q1 q2 by r square. This is the mathematical form of Coulomb's law. The value of the constant in CBSE unit is 1, and in SI unit the value of the constant is 1 by 4 pi epsilon 0. Where epsilon 0 is called free space permittivity, the value of epsilon 0 is 10 to the power minus 9 by 36 pi farad per meter. Now 2 points has to be remembered about Coulomb's law. Number 1 is the charges which we are considering, they has to be at rest condition, otherwise Coulomb's law is not applicable, because which we are talking about, it's electrostatics. So the charges has to be at rest condition or static condition. So number 1 is the charges are at rest condition, and number 2, the charges has to be point charge. So these two facts you have to remember about Coulomb's law, otherwise Coulomb's law is not applicable. Now let's talk about the force which is acting between the two charges, that may be either repulsive or attractive, that depends on the nature of the charges. So this force is definitely a vector quantity, so we should look forward for the vector form of Coulomb's law. So let's find the vector form of Coulomb's law. To find the vector form of Coulomb's law, a little bit modification in this previous diagram has been done. Here are the two charges q1 and q2, and one origin is considered here. O is the origin, and the distance from the origin to the charge q1 is considered as r1. This is a vector r1, and the distance from the origin to the charge q2 is vector r2. So the distance between q1 and q2 is r2 minus r1. You can see the triangle here and apply the triangle law of vector addition, from where you can write that this vector is basically subtraction of r1, subtraction of r2 and r1. That is, this vector can be written as r2 minus r1, as this two is taken in same sequence and this one is in opposite sequence. So this is the resultant of these two. So basically r2 is equal to r1 plus r. So r is r2 minus r1. This r is defined as r21. This is written here, r21 is equal to r2 minus r1. So from the Coulomb's law, I can write the force, as these two charges are taken as positive. So the force on q2 due to the charge q1 is F21 is equal to 1 by 4 pi epsilon naught q1 q2 divided by r21 square, and the direction of the force will be in this direction, because the force on q2 due to the charge q1 will be repulsive. The direction of the force is along r21, so it is defined as an unit vector along this direction as r21 cap. So the force will be like this. This is how the force on q2 due to the charge q1 can be written as. Now from the definition of unit vector, we know that r21 is equal to vector r21 divided by modulus of r21. So using this one here, I can write F21 is equal to 4 pi epsilon naught q1 q2 by r21 square into vector r21 divided by r21. So it becomes 1 by 4 pi epsilon naught q1 q2 by r21 cube into vector r21. So this is the form of F21. In a similar way, the force on q1 due to the charge q2 can be written as F12 is equal to 1 by 4 pi epsilon naught q1 q2 divided by r12 square into r12 cap, because now the force will be directed in this way. So it can be written as r12, which is opposite to r21, where unit vector r12 is equal to r1 minus r2. Now from the definition of unit vector I can write it is equal to 1 by 4 pi epsilon naught q1 q2 divided by r12 square into vector r12 divided by r12 mod. It is the scalar value of r12. So I can write 1 by 4 pi epsilon naught q1 q2 by r12 cube into r12 vector. So this is the form of F12, the force on q1 due to the charge q. Now one thing you know, that the factor that r21 or r12, whatever be the factor, is a basically scalar quantity, and we know that r12 modulus of r12 is equal to r21. When we consider these factors as a scalar, then it does not matter it is r21 or it is r12, it does not matter, because we are considering the value of the vector, not we are bothering with the direction of the vector. So that r12 is basically equal to r21. That is why this factor can be replaced by q1 q2 by r12 is replaced by 21 cube, because it is a scalar, it can be done. Now look at the factor r12 vector, sorry, r12 vector. Now the vector r12 is written here, that is r1 minus r2. Now if I take a minus sign common here, so it becomes r2 minus r1. Now that r2 minus r1 is r21, so it is minus r21. That is r12 vector is equal to minus r21 vector. So I can write here as r21 with a negative sign. Now if I take this minus sign out here, so it becomes 1 by 4 pi epsilon naught q1 q2 divided by r21 cube into vector r21. Now this is nothing but f21, therefore I can write it as minus f21. So it becomes f12 vector is equal to minus f21 vector. It means that the force which is acting on the charge q1 by the charge q2, that is f12, is exactly equal and opposite to the force which is acting on q2 due to the charge q1, which is basically Newton's third law. So we can also demand that Coulomb's law obeys Newton's third law. But if you are simply asked to write the vector form of Coulomb's law, then you can simply write either of these two equations, this f21 or f12, whatever you like. Either of this equation you can write as the vector form of Coulomb's law. Okay. So next I will go to the topic, that is comparison between electrostatic force and gravitational force. As you have already seen that the force acting between two charges, two point charges which are in rest condition, is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This law is very much similar to the Newton's law of gravity, where it is stated that the force between two point masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. That means there should be some similarities between the Coulomb's law between two charges and law of gravity. So let's start the comparison between Coulomb's law, rather the electrostatic force and gravitational force. First of all, we will discuss the similarities between two forces, then we will discuss the dissimilarities between two forces. So, the similarities between the two forces are here. Number one, both of the forces obeys inverse square law, that is, both of them is proportional to 1 by r square. Number two, they both are conservative. Number three, both the forces acts in vacuum also. Similarly, number 4 is both the forces are central force. Now let me clear that what is central force. Central force is that kind of force which can be expressed as a function of r and it is directed away or towards a origin. That is, the forces which can be expressed as vector f is equal to function of f and directed along r. Such type of forces are called central force, and both the force electrostatic and gravitational obeys this nature. So they can be so it can be stated that both the forces are central force. And the next similarity is both of the forces obeys Newton's third law. And another important fact, so let me write the similarity number 5, that both obeys Newton's third law. And the sixth similarity between the two forces is both of the forces are spherically symmetric. It's very important. It is both of the forces are spherically symmetric. So here are the 6 points to be remembered. There are the 6 similarities between electrostatic force and gravitational force. Now let us discuss the dissimilarities between the two forces. The dissimilarity number 1 is the gravitational force is very weak compared to the electrostatic force. That means this force is very weak, and the electrostatic force is very strong in nature compared to gravitational force. Now let me clear that don't get confused with the word that weak and strong. Basically I am talking about the strength of the force. The strength of the gravitational force is weak compared to the electrostatic force. It is not at all a weak force. Weak force is something related to beta emission, which I am not discussing. Now the second similarity, second dissimilarity is that the gravitational force is always attractive in nature. It is always attractive, but it may be attractive or repulsive. And the third dissimilarity between the two forces is that gravitational force, it does not depend on the medium between the two masses, that is, it is medium independent. But the electrostatic force between two charges depends on the medium between the 2 point charges. That means it is depends upon the medium. So here are the 3 dissimilarities between gravitational force and electrostatic force. So let's go forward with the next topic, that is the unit and dimension of epsilon 0. To find the unit and dimension of epsilon 0, we have to start from the mathematical form of Coulomb's law, which is written as the force of attraction between 2 point charges at rest is F is equal to 1 by 4 pi epsilon naught into q1 q2 by r square, which I have already stated. To find the dimension of epsilon 0, it can be written as 1 by 4 pi epsilon 0 is equal to q1 q2 over f into r square, from which we are basically determining the dimension of epsilon 0. Now this 4 pi is a constant quantity, so it can be dropped, and the dimension of epsilon 0 can be expressed like this. So the dimension of epsilon 0 is the dimension of q1 and q2 over the dimension of force and the dimension of r square. Now the dimension of charge can be found as we know that current can be expressed as q by t. So the dimension of q is dimension of current and dimension of time. Now we know that the dimension of current is A and dimension of time is capital T. So the dimension of Q, the dimension of charge is A into T. So the dimension of Q1 is A into T, as well as the dimension of Q2 is also A into T. So it becomes like this, and the dimension of force we know that it is ml T to the power minus 2, and the dimension of distance is L, that is a square. So the dimension of epsilon 0 can be found to be 80 square divided by ml T to the power minus 2 divided by L square. So the dimension of epsilon 0 can be found as m to the power minus 1, L to the power minus 3, this one is square and this one is L to the power minus 3, it becomes T to the power, here is 2 and here is also 2, so it becomes T to the power 4 and A to the power 2. So this is the dimension of epsilon 0. Now I have to find out the unit of epsilon 0. From this equation you can find the unit of epsilon 0. This 4 pi has no unit, so I am basically determining the unit of epsilon 0. As we know that in SI system the unit of charge is Coulomb, so it Coulomb square divided by the unit of force in SI system is Newton, so it is Newton per meter square. This is the unit of epsilon 0. Let's move towards the next topic, that is dielectric constant. As in the topic 4 I have stated that the electrostatic force is medium dependent force, whereas the gravitational force is independent of the medium. So if two point charges are placed in free space, in that case the force between these two charges Q1 and Q2 can be written as F free is equal to 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of the medium of the free space, that into Q1 Q2 by R square. But if the in a medium in between these two charges is filled with some material medium whose permittivity is written as epsilon, in that case the force between two charges can be written as 1 by 4 pi epsilon into Q1 Q2 by R square. So this equation represents the force between two charges in free space, and this equation represents force between the same two charges when the space between the charges is filled with some medium of permittivity epsilon. Now if we divide the equation 1 by equation 2, then we will get F free over F medium is equal to epsilon by epsilon 0. This ratio epsilon by epsilon 0 is defined as dielectric constant. So physically dielectric constant means that Fm is equal to F free over K. That is, when the space between two charges is filled with some medium, then the force between these two charges will be reduced by a factor dielectric constant. This equation represents that the force between two charges in that medium is equal to the force in that force between two charges in free space over K. That means the force has been reduced by a factor K. This is the physical meaning of dielectric constant, and it can be also defined as the ratio of epsilon over epsilon 0, where epsilon is the permittivity of that medium and epsilon 0 is the permittivity of free space. One thing you have to remember here, that the dielectric constant is a dimensionless quantity, as it is the ratio of two similar kind of quantities. It is the ratio of two forces, so it is a dimensionless quantity. One question is generally asked here, that the dielectric constant of mica is 5.4. What does it mean? Let's discuss the answer. The dielectric constant of mica is 5.4. It means that if the force between two charges in free space is F, and if you fill the medium, if you fill the space between two charges with mica, then the force will become F prime is equal to F over 5.4, where F is the force between in free space and this F is the force when the medium is filled with mica. So that's all about dielectric constant. Next topic is superposition principle, and it is the last topic of today's video. and it is the last topic of today's video. So that's all about dielectric constant. Let's move to the last topic, superposition principle. Which is, to understand superposition principle, let us consider 5 charges Q1, Q2, Q3, Q4 and Q5, where we have to determine the force on Q1 exerted by all the other charges. The force on Q1 due to the charge Q2 is along this direction, which is written as F21. Similarly, the force on Q1 due to the charge Q3 is along this direction, which is nothing but Q31. Similarly, the force on Q1 due to the charge Q4 is along this direction, which is F41. Similarly, the force on Q1 due to the charge Q5 is along this direction, which is F51. So the net force acting on the charge Q1 is F1 is equal to the vector summation of all the individual forces that acting on Q1, that is F1 is equal to F21 plus vector F31 plus vector F41 plus vector F51. This is superposition principle. So superposition principle is the force acting on any charge is the vector sum of all the individual forces that acts on the charge, which can be mathematically expressed as this one. And if there are more number of charges, say there are n number of charges Qn, in that case it can be written as F21 plus F31 plus dot dot Fn1. So it can be also expressed as sum over Fi1, where I extends from 1 to n. This is the net force on Q1 due to all the other charges. It is basically superposition principle. From superposition principle, some numericals are generally asked. In my next video, I will discuss some numerical problems based on superposition principle. Thank you very much.